I'm Mike Liberman. I'm a co-founder of a supply chain security startup called Kusari. I'm very much focused in the open source space. And I'm also a member of CNCF, a lead on their tag security, as well as a maintainer of some couple of OpenSSF projects, including being on the SALSA steering committee. By a show of hands, how many people have heard of software supply chain security before? Okay, a few folks. So I'll give a little bit of an introduction into what software supply chain security is, and go from there. And then one more question, by a show of hands, how many people have heard the terms SBOM or software bill of materials? Okay, a few folks. Okay. Hopefully can provide an explanation there. All right, so what's the problem, right? So the problem here is software supply chain security is just SDLC security, right? How are you securing from developer to production, right? And the problems, of course, are, a developer, either authorized or unauthorized, could be, committing bad code, malicious code with, vulnerabilities. Your source code repository could get compromised. When your build pulls from the source code repository, you could be pulling from the wrong one, right? And then when you go and package it all up and push it out, right, there's issues there, right? How do you know that you're actually deploying the package that you thought you were deploying, and so on? And the real big issue is this one right here, dependencies, right? So when looking at dependencies, right, this is third-party risk management. This is a lot of stuff that's often coming from outside the organization, right? And these are things like your log4js, right? For folks who've heard of what happened there about a year ago, right? Log4j, massive vulnerability. A lot of folks were spending a lot of time to try and figure out where that is, right? And so yeah, that's kind of the summary of the problem, right? And one of the solutions, right, is we need data, right? We need to know what's living where. We need to know who wrote the code. We need to know where we downloaded it from and all that great stuff. Which then, and also before I forget, for anyone who wants to follow along, there's actually, well, the QR code maybe is not be able to read, but they'll have stuff later where you can follow along. You could just go to https guac.sh if you want to follow along with the demo later. So then, what's the problem within the problem, right? Our software supply chain is complicated. It's a little hard to see, but each of these is like a little dot, right? And each of those is a package. And those are not necessarily packages you yourself have created, right? These are not your projects. These are the projects that your projects rely on. So, if you have a Maven project, right? You're using Java, you rely on Spring, you rely on Log4j, great. And the problem is, like, you think you just have a couple of layers of that, but you actually have a ton, right? You have your Java relies on, Log4j relies on something else, and so on and so forth. And then you also rely then on the JVM, and the JVM is sitting on top of Linux, and and Linux has its own set of dependencies and so on. So, right. So when you're looking at this, you're like, great, there's another log4shell sort of situation going on where there's there's a big vulnerability. We need to discover it. Where is it? How can you tell, right? Which one of those dots is an end-of-life package and you should be upgrading it? Which one of these dots is malware, right? And which one of these dots has like a license that we shouldn't be using and we could get sued over? So why is this a problem, right? And so there's too much data, right? Like you look at that and you go, how could I possibly figure this out, right? For folks who are, most of you probably haven't heard of SALSA, but SALSA is a build framework, a build security framework. There's SBOMs, which are what I said before, which is sort of a software bill of materials, which at a very high level is just a description of all the dependencies of a piece of software. So if you have, if you're running a Python project and you rely on Django, okay, so it's you have it would list Django and Django's dependencies and so on. And then there's other sorts of information that's coming in from the outside world, right? There's an open source API called OSV. which has a bunch of information around open source vulnerabilities. There's something called IT6, which is in toto attestations, where there's a bunch of information and metadata coming from the supply chain there. You could also imagine vulnerability scans. So I don't know if folks use Veracode, Black Duck, those sorts of things, right? There's a bunch of data coming from all these different places, right? So that's one piece of it. And then in addition to that, there's also too little data. The data quality is often poor in this. A lot of folks who look at this, they kind of say, hey, it gives me some information, but not everything. And it leads to sort of an unknown problem. We don't know what we don't know, which is a huge issue, right? There's a gap here, right? We have information about these dependencies, but not everything. And then, the big thing, right, is if you don't know about a threat, doesn't mean it's not there, right? And then the other big thing is we want to better understand the relationships between all this data. We want to understand, hey, if I rely on this, what does that mean? Who's written that code, and have they written similar code elsewhere, right? So what do we need? Well, we need tools that stay out of the developer's way, right? So we come from the standpoint of, we used to be, DevOps, DevSecOps, front end and back end, or mostly back end developers. And so we realize we want to stay out of the developer's way. We don't want that sort of thing that you learn right before you're about to go live. Hey, there's a vulnerability here. Got to push back the go live by a week, right? We want to tell you right then and there what's the problem. And so we need systems that are easy to manage, configure, and operate, right? And we need consistent enforcement of that policy, right? You don't want to have a million different tools giving you slightly different views into the problem. You want to have one major database that you can kind of look into. And so all of this isn't possible if you don't have that data store. And so you kind of want to have this thing that starts to begin to connect the various dots, so you know what's actually in the path that you care about. And so what is GUAC? So GUAC is an open source project, co-led and co-created by ourselves, Kusari, as well as Google, with a lot of input from Purdue University, as well as Citi, the bank. And it's a knowledge graph of software metadata to answer security and supply chain questions. And so when thinking about sort of how do you secure your SDLC, how do you do this software supply chain security, this is kind of what the basic sort of architecture looks like, super simplified, right? And GUAC is here, right? You have all of this knowledge about what you're pulling in, who wrote what code, and so on. And then you have something that is sort of managing, you would have a policy engine, whether it's OPA or something similar, Open Policy Agent for folks who are familiar with that, that can then sort of control based on this information, what should be allowed, what shouldn't be allowed. So endpoint protection, like what should developers be allowed to install, right? Are developers installing anything malicious? Secure ingestion, right? Are you ingesting only the dependencies you think you're supposed to, and only dependencies that are good? Secure dev, right? Like, are you writing the code in a secure environment where that stuff isn't leaking? Secure software factory, are you building the code in a secure way? And then finally, it's like software authorization. Is the code that is the packages and the builds that you've made, have they gone through all the right steps and you've checked all the right things, and is it good to go? And then all of this feeds back into that same graph. And then to kind of talk a little bit more at the depth level, right? You want to have a trust foundation, and a trust foundation is just, hey, are you signing the things, right? And there's a, for folks who aren't aware, there's a PKI sort of tool out there, an ecosystem called SigStore, which allows you to, it's much easier than GPG, PGP, and lets you do stuff like, signing commits very easily, signing packages, signing your SBOM, signing attestations, which are claims on software. And then those software attestations are the next sort of level there, right? You want to say, great, I trust these people to do these sorts of things. And are they doing those sorts of things? And are they signing that, that you went through a security scan and all that great stuff? Then you have sort of an aggregation and synthesis level where you kind of come in and, that's where GUAC is, where it's the database. And then finally, you have sort of your policy and insight on top. Okay, so what supply chain and security questions do we actually want to answer? Well, we want to answer sort of proactive ones, right? Which, in this sort of big picture here, right? How do I prevent large scale supply chain compromises? Like this is, from the XKCD, right? Where, hey, this package right here is potentially one that you rely on and is super important and you don't realize is in the critical path. An example being Perl compatible regular expressions. Everything relies on Perl compatible regular expressions. And then you also want to do like preventive questions, right? Have I taken the right safeguards? Am I running the right security scans? Am I running it through the right secure builds and so on? And then finally, reactive, right? Where you want to be able to say, great, there's something that we didn't know about, another log4j. It wasn't our fault. It was just something that happened. Somebody discovered that there's a vulnerability in it. Where does that live in my ecosystem? Do I know? And so that's where, that's another question that GUAC is supposed to solve. And then how it does this is by sort of ingesting all of this data and turning it into essentially a giant graph, right? Where we have information about the artifacts, attestations, who made those attestations, and the relationships between them. And so really there's two types of queries that come out of GUAC. One is, I want to query properties of my software, like which software is affected by a particular vulnerability, as well as another one is like sort of a temporal bit of information. Like, so for folks who are involved in compliance, right, you want to know, what did I know when? So when the regulators come in or lawyers come in and they say, hey, did you know that you were exposed to this? Well, you can look at the database and say, at this time, this is what we knew. And then in addition to that, there's evidence sort of based queries like, what sort of information, what sort of evidence do I have related to the different artifacts I have, and does that meet some sort of policy? And so GUAC is going to be two things. One is it's going to be a public service. It's going to take a little while to get out there, but it will probably contain something like the top 1% of open source software, where we'll ingest a ton of open source metadata about it. It'll be queryable by the public. And it'll also, you can run this as an organization and ingest all the information about, your supply chain, your metadata documents, your SBOMs, your SALSA attestations, and so on. And there's also going to be some upcoming integrations like VS Code, so that you can actually find out right then and there, like as opposed to right before you're about to go live, oh no, I'm using an end-of-life version of this library, or I was supposed to update, or I'm supposed to use a different one. This thing can run queries and policy against that and be able to know, like, hey, this was a malicious package, don't use that one. For example, the requests versus request thing that happened a while back, where there was somebody who had typo squatted. They created a Python package called request, a very popular Python package called requests, and it led to a lot of folks getting compromised. So right now, we're GUAC beta v0.1. We have, you can ingest SBOM, SALSA documents, a bunch of different things. We have a web UI, which I'll show actually right now. Okay. So very quickly here, I'm going to switch over. So just real quickly, I'm going to run a query here. And just, so here I'm running a query, pretty much just saying, hey, this vulnerability over here, this GHSA vulnerability, this is just a log4 shell vulnerability. For folks who weren't aware, right, there was a big thing about a little over a year ago, I think. Oh, do you need it? Oh, yes, I didn't realize. Okay. There we go. Let me do that again. And so there was this giant, vulnerability where pretty much anybody could actually, not anybody, but if it was exposed the right way, anybody could get into your, it could essentially run remote code execution through this log4j vulnerability, and that included through the internet. And so we can run this query. We can see it sort of in this format. And 1 second. And let me put this down. And you, let me see, is that, yeah, let me increase the size there a bit. And so here's the UI, and if folks know people who want to work on an open source React project, because us backend and DevOps engineers are not the greatest UI folks, please contact me. And so here you can see, there's this vulnerability. This vulnerability is associated with log4j 2.8.1, and you can see it came from Maven, and here's all the information that's sort of related there. And there's other things that we can actually do if we wanted to, where we can actually click in at some point. But I can pull up other information as well. You can pull in, other sorts of stuff. I'll just pick something random. Okay, it's not working right now, but anyway, yeah. So that's kind of the UI there. I go back to the slides. So that's just kind of a very, very, very basic introduction to GUAC. And so once again, GUAC is an open source project. We're always looking for more folks to kind of come join the community, come contribute. It's open to anybody. Doesn't matter if it's written in Go, but if you don't know Go, it's fine. We're interested in just hearing, hearing feedback. Feel free, if you run it, open up issues, discuss your use cases. All are welcome. Let me see. The QR code on the right is GUAC. The one in the middle here is just my LinkedIn. If folks wanted to contact me and discuss more about either supply chain security, SBOMs, GUAC, any of those sorts of things. Yep. Pretty much anything that we can pull in from that you would consider part of the supply chain, we do want to pull in. One of the core goals for us as well is to kind of pull in information about what assets are coming in. So like, what's the hardware, right? What, is that hardware, whether it's like a MacBook or a server or whatever, because that's also part of the supply chain, and they call that sort of the bottom turtle problem, which is just, there's always like, whatever you're doing, there seems to be one more turtle beneath it that you need to worry about. And the thing when it comes to supply chain security is you're trying to kind of root in a reasonable bottom turtle, right? Where you might say, hey, you know what? If I'm down to the firmware, I've probably solved most of my issues. But yes, that's on the roadmap. Yeah, so JFrog works at the sort of ingestion level. We're trying to do the full sort of life cycle from source to all of that, and then that it would include ingesting information from JFrog. So we're trying to do all of it, right? So the idea would be you might be pulling in and doing ingestion at that level, and what we want to do is say, hey, complement that information first off, and second off, actually ingest the information that we're seeing from JFrog to then complement all the other stuff, right? Because in many cases, it's like, oh, I downloaded this thing, but where is it actually now installed in my ecosystem, right? And that's kind of the worry, is that all of a sudden JFrog says, whoa, 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 hold on. We discovered that this thing is a huge problem. Okay, cool. Where is it installed? I don't know. Well, okay. Well, if we record all of that information, then we can sort of respond to that as well. That I'm not sure. We're in discussions with a lot of different folks on this. So from the open source end, we're working with all the open source providers who will provide that information. And then Kusari as a business, right? We're interested in partnering with whomever wants to work with us on that. Yes. Yeah, so there is a thing called VEX, which is, it's referred to Vulnerability Exploitability Exchange, I think, something like that. It's essentially, it's a document that you can sort of certify or attest to. This application is not actually vulnerable to this thing because of some reason, right? And so we also ingest those documents as well. So if you have a VEX document, it's like, hey, this is claimed not to be vulnerable for this reason.